Welcome to this podcast episode brought to you by AGS Agriculture Global Solutions, your partner for better oil palm farming. Today we are taking a deep dive into keeping your most valuable assets, your topsoil and nutrients, exactly where they belong. Because stopping soil erosion on sloping land is the ultimate secret to unlocking your total crop yield potential. Register now on CropDrive.ai. Use the tool completely free of charge, no hidden fees, no conditions. CropDrive helps you improve your oil palm growing skills. Subscribe to our channel so you do not miss key oil palm best practice episodes. So, imagine walking into your field, pulling out your wallet, and just throwing 30% of your hard-earned cash directly into the nearest river.
Oh, yeah. That is a painful image.
All right. But honestly, if you are managing oil palms on a hillside right before a heavy monsoon rain and you don't have any soil defenses in place, that is essentially what you were doing. You're just watching your profits wash away.
Yeah.
It really is a brutal reality for a lot of smallholder farmers today. I mean, farming is naturally expanding into more marginal hilly areas. And, well, with that comes the challenge of gravity.
Yeah, gravity always wins.
Exactly. So to understand how we actually stop that cash, which, is your fertilizer and your topsoil from just washing away, we are looking at a really pivotal 2017 study out of Malaysia.
Right. And this study is super interesting because of where they set it up.
Yeah, the researchers specifically set up on these marginal sloping lands because they wanted to measure the actual mechanics of soil degradation during heavy rainfall. And more importantly, they tested various agronomic conservation methods to see which ones actually changed the physics of the slope, trapping water and nutrients to boost the site's yield.
Because the core problem we were looking at here is what they basically call the invisible thief. When surface water rushes down a slope, it takes the topsoil with it.
Yeah.
But I think we really need to define what topsoil actually represents to the palm, right?
Oh, absolutely.
Because it is not just the dirt holding the tree up. The topsoil is, well, it's the sponge.
That's a great way to put it.
Yeah, it holds all the organic matter, and it acts as a magnet for the applied fertilizers. So once that upper layer strips away, you are just left with subsoil. And that subsoil is often dense, it's acidic, and it acts way more like a concrete parking lot than a sponge.
Right,
Yeah.
Which triggers just a devastating chain reaction for the plant. First, you get the rapid loss of those really expensive fertilizers you just applied. I mean, they bind to the topsoil particles, so when the soil goes...
The nutrients go right with it.
Exactly. The nitrogen, the potassium, it all goes, leading to severe nutrient deficiency. And second, because you have lost that spongy organic matter, you get a severe reduction in the soil's water holding capacity.
Because the water just hits that hard clay and runs off.
It just sheets right off that hard subsoil, yeah.
Yeah.
So when the dry season inevitably hits, your palms experience severe water stress. And a palm simply cannot produce fruit bunches when it is starving and thirsty at the same time.
Okay, let's unpack this. If you picture your farm on a slope during a massive rainstorm, it is almost like carrying a backpack full of your most valuable supplies. But you left the zipper completely open.
Oh, man, yeah.
Right.
Yeah.
The second you start walking uphill, everything you need, your water, your food, your fertilizer, it just falls right out and rolls down the mountain.
That is a perfect analogy. The environment is actively working against your physical labor. And this brings us to an absolute physical limit that the Malaysian study highlights, which every farmer really needs to respect. And that's the 40-degree rule.
A 40-degree rule.
Yeah. Basically, planting on anything steeper than a 40-degree slope guarantees major land degradation, period.
Let's talk about the physics of that for a second, though. 'Cause
Right.
Why 40 degrees specifically? It seems like kind of an arbitrary number, but I am assuming there is a structural reason why the land just gives up at that angle.
Right, it's not arbitrary at all. It basically comes down to soil shear strength, which is essentially the natural friction that keeps the top layer of dirt bonded to the mountain underneath it.
Okay, so like the glue holding the hill together.
Exactly. And at angles steeper than 40 degrees, when that soil becomes fully saturated with heavy rain, well, the weight of the water actually overcomes that natural friction. The soil physically cannot hold on to itself anymore.
Wow, so it just slides.
It does. The research is completely definitive on this. There should be no lining, no terracing, and absolutely no planting on these extreme slopes. I mean, gravity and water velocity will inevitably cause landslides, which destroys the environment and completely wastes your investment.
Okay, but let me push back on the nutrient loss aspect for a moment. Because if rain is the trigger that washes the fertilizer out of the backpack, can't a farmer just outsmart the rain?
How do you mean?
Like you check the weather forecast, you time your fertilizer applications for a dry window, and you just avoid applying right before a storm. Wouldn't better timing solve the nutrient deficiency problem without having to do major earthworks?
Well, if we connect this to the bigger picture, timing your applications is absolutely best practice, no doubt about it. The study noted that urea fertilizer losses can easily exceed 30% if you put it down right before bad weather.
30%. That is a huge financial loss.
It is massive. So, yeah, avoiding application before a monsoon definitely saves you money in the short term. However, and this is the big catch, timing does not stop the soil itself from disappearing.
Ah, I see.
Right? It doesn't stop the loss of the natural organic matter, which, as you said earlier, is the very thing that holds the moisture for the dry season. So to truly protect your long-term yield, you have to physically alter the landscape to slow the water down. You have to zip the backpack closed, essentially.
Which brings us to the first major intervention on the farm, which is earthworks. Since we cannot just turn off the rain, we have to change the geometry of the hill to handle it.
Precisely.
And the study looks at contour terraces, which are basically flat steps carved into hillsides that are greater than 6 degrees, right?
Yep. They physically interrupt the water rushing down.
But honestly, as a farmer, the idea of terracing sounds kind of counterproductive. I mean, you are bringing in heavy machinery or you're spending weeks with a shovel, literally scraping away the very topsoil we are trying to protect.
Yeah, it's a really valid concern.
Because you are cutting deep into the subsoil, you're compacting the ground and disrupting the root zone.
You're not wrong. The damage to the initial soil structure is significant. Constructing those terraces removes that fertile upper horizon, and the resulting soil compaction temporarily just plummets the soil fertility.
Right, because water cannot infiltrate compacted soil easily.
Exactly. The 2017 study acknowledges this massive drawback, which is why they point to silt pits as a much more powerful, less destructive alternative, or, a necessary addition if terraces already exist on the farm.
Okay, so let's visualize these silt pits. Looking at the field diagrams from the deep dive, they just look like close-ended trenches dug between the planted rows of oil palms.
Yeah, that's basically it.
And they are usually less than 1 meter deep, so we are not talking about digging massive canyons here. But let's be real, hand-digging trenches every 20 or 30 meters across an entire farm is back-breaking labor. I can already hear farmers groaning at the thought of it. Why is it worth the sweat?
I get it. It sounds like a lot of work. But the return on investment for that physical labor is absolutely staggering. These silt pits act as miniature reservoirs spread across your entire farm.
Okay, so how do they actually catch the invisible thief?
Well, when heavy rainfall turns into surface runoff, the water starts picking up speed down the hill. But before it can build enough momentum to wash away your topsoil, it falls into one of these trenches.
Oh, so it just drops in.
Right. The pit traps the water, and more importantly, it traps the soil sediments and the fertilizer that the water was carrying. So instead of running off into the river, all those nutrients pool right into the trench.
And because it is close-ended, the water can't go anywhere. It just sits there and is forced to slowly infiltrate deep into the soil profile right next to the palm's root systems. It is essentially an underground savings account for moisture.
That is exactly what it is. And the data from the Malaysian study quantifies just how big that savings account actually is. Implementing these silt pits literally deferred soil dryness by up to 3.5 months compared to sloping areas with no trenches.
Wait, really? 3.5 months of extra moisture?
Yep, 3.5 months.
Wow. When the dry season hits, that is literally the difference between a palm tree going into survival mode and dropping its fruit versus a tree that continues to steadily produce high-yielding bunches.
Exactly. So the actionable advice here is to really evaluate the steepness of your farm. You need to dig these silt pits at 20 to 30 meter intervals along the contours of the hill.
Okay, 20 to 30 meters.
Right. But if your slope is on the steeper side, say closer to 30 degrees, or if you already notice severe erosion happening, you need to space them closer together, around that 20-meter mark, just to handle the increased water velocity.
Got it. So we have reshaped the earth with these trenches. But, a really intense monsoon can still overflow a silt pit, right?
Oh, sure. In extreme weather. Absolutely.
Right. And what happens to the bare dirt between those trenches when the rain is just pounding down? We need to armor the surface somehow. And thankfully, nature provides free materials right on the farm to do this. So let's talk about organic speed bumps, starting with the most obvious resource, pruned fronds.
Yes. I mean, every oil palm farmer is regularly cutting away older fronds during harvesting and maintenance, and often these are just left in random, messy piles.
Just lying around wherever they fall.
Right, but deliberate placement changes everything. The study highlights that stacking these pruned fronds in an L-shaped pattern or, laying them continuously along the natural contours of the hill, meaning they lie perpendicular to the slope, creates a highly effective physical barrier.
Here's where it gets really interesting. It is all about the physics of water velocity. It is exactly like hitting a speed bump in a school zone.
Oh, I like that.
Yeah. When you are driving fast and hit that bump, you are physically forced to brake. Water works the exact same way. The faster water moves, the more sediment and weight it can carry. But when that sheet of rushing water hits a solid wall of stacked fronds, it just loses its momentum.
Right, it hits the brakes.
Exactly. And because the water slows down, it loses its carrying capacity, and it just drops the stolen sediment and nutrients right back onto the soil surface instead of taking them off the farm.
And that mechanical slowing of the water is incredibly effective. I mean, the research demonstrated that this simple practice of contour stacking your own pruned fronds cuts soil erosion down to less than 5 tons per hectare per year.
Less than 5 tons. That's amazing.
It really is. You are drastically minimizing soil loss just by organizing the biological waste you already produce anyway.
That is a phenomenal mitigation strategy for literally zero material cost. But the study also looks at importing other organic mulches, right?
Yeah.
Specifically empty fruit bunches, or EFB, because I know a lot of mills just have mountains of these left over after the oil is extracted.
Yeah, empty fruit bunches are essentially a super mulch. When you apply them to the bare soil surface around the palms, they act as a massive biological sponge. They improve soil aeration, they massively increase the water holding capacity, and they protect the bare dirt from the physical impact of heavy raindrops.
Right.
But the real magic happens as they slowly decompose. They release a tremendous amount of locked up nutrients directly back into the soil.
Okay, let's break down the chemistry of that because the numbers in the deep dive are wild. Applying 1 ton of EFB is roughly equivalent to applying 7 kilograms of urea.
Right.
And urea provides the nitrogen that gives the palms that deep, healthy green color and drives vegetative growth. But you're also getting about 3 kilograms of rock phosphate for root development, plus over 19 kilograms of muriate of potash, which builds drought resistance and bunch weight, and over 4 kilograms of kaiserite, which delivers the magnesium necessary for photosynthesis.
It's incredible, right? You are quite literally laying down a slow-release, broad-spectrum commercial fertilizer entirely organically. However, and this is a big however, this raises an important question about logistics for the smallholder farmer.
Yeah, the transportation part.
Exactly. Empty fruit bunches are incredibly heavy because they retain a lot of moisture from the milling process. They are bulky and they are very difficult to transport.
Right. If you are farming 20 kilometers away from the nearest mill, hiring trucks to haul tons of wet, heavy organic matter up a dirt road into the hills is just going to eat up any financial benefit you get from the nutrients.
Exactly. The economics really only make sense if your farm is located very close to the mill. If you are dealing with high transportation and labor costs just to get the EFD onto your property, the strategy fails.
It's just not worth it at that point.
No, it's not. So for the vast majority of smallholders who do not neighbor a mill, relying on your own pruned fronds, strategically stacked along the contours, remains your absolute best, most cost-effective line of defense.
Keep it practical, keep it local. I love it. All right, so we have reshaped the earth with silt pits, and we have laid down organic armor with our fronds. The final phase in transforming our degraded land into a productive system is bringing in living shields. We need to lock everything into place with biology.
Yes, biology is the final piece of the puzzle, the absolute gold standard practice immediately after land clearing, or honestly anytime you have wide stretches of bare soil exposed on a slope, is the establishment of leguminous cover crops, or LCCs.
Okay.
The study specifically looks at species like Mucuna bracteata.
Now, if I am a farmer, I already spent half my life fighting weeds. So the idea of intentionally planting a fast-spreading vine across my entire farm feels terrifying. Won't this Mucuna bracteata just climb up my young oil palms and completely smother them? Aren't we just trading one problem for another?
Well, it is a very common fear, and it is true that Mucuna bracteata is aggressive. It definitely requires management. You have to maintain clean circles around the base of your oil palms to prevent the vines from climbing the trunks. But the trade-off for that extra circle weeding labor is enormous. Natural weeds just steal water and nutrients from your palms, but leguminous cover crops, They are actively working for you,
because they pull fertilizer out of the thin air.
literally. Because they are legumes, they have this amazing symbiotic relationship with bacteria in their roots that allows them to fix atmospheric nitrogen and convert it into a form the soil can actually use. They're constantly pumping nitrogen into the ground.
That is so cool.
And on top of that, their broad leaves act like an umbrella, intercepting the kinetic energy of the rain so it doesn't shatter the soil structure.
So it softens the blow of the monsoon.
Exactly. And as they drop leaves, they continuously build up that spongy organic matter we talked about earlier. Plus, they outcompete the harmful, noxious weeds, just shading them out completely.
So you are basically hiring a full-time, self-replicating groundskeeper that fertilizes the soil, stops the rain impact, and chokes out the bad weeds. That's a pretty good deal.
It's an incredible deal. And to finish securing the farm, we need to zoom out from the planted rows and look at the absolute edges of the property. This brings us to the management of riparian zones.
Okay, so riparian zones, just to define that clearly for everyone, we are talking about the natural, wild, vegetative buffers, like the native trees, the shrubs, and those deep-rooted grasses that grow naturally along the banks of streams, rivers, and lakes.
Right, the green belt along the water.
Exactly. And if you own land that borders a river, there is always this temptation to clear cut right up to the water's edge just to squeeze in, 3 or 4 extra rows of oil palms.
Oh, it's so tempting for farmers to want to maximize that space. But what's fascinating here is how the science shows that clearing that final edge is a catastrophic mistake for the broader environment and your local water quality. Those riparian zones act as a massive natural biological filter for the entire plantation.
Because, no matter how many silt pits you dig or how many fronds you stack, in a torrential monsoon, some surface runoff is eventually going to make it to the bottom of the hill.
Yes, surface water will inevitably reach the boundary. But before that runoff can crash into the river, it has to pass through the dense, tangled undergrowth of the riparian zone. The physical stems and trunks of those wild plants act as a final speed bump, catching the very last bits of suspended sediment.
It's just filtering the dirt out.
Exactly. But even more importantly, the extensive, really deep root systems of that natural vegetation actively absorb dissolved nutrients.
Okay, so what does this all mean for the fertilizers we talked about losing earlier?
It means that if some of your applied nitrogen or potassium dissolves into the runoff water, the wild roots in the riparian zone will actually drink it up before it can enter the watercourse.
Wow.
Yeah, if you clear that zone, those agricultural chemicals dump directly into the river, polluting the local ecosystem, causing algae blooms, and really just degrading the water supply for everyone downstream. The natural vegetation stabilizes the riverbank, it prevents the land from collapsing into the water, and it keeps your farming practices sustainable.
The actionable takeaway is incredibly clear. Leave the greenbelt alone. Never clear, spray, or plant your oil palms right up to the edge of a riverbank. You just have to let nature run the final filtration system.
Exactly. When you combine all these practices, you completely alter the fate of a sloping farm. You literally stop the invisible thief. By respecting the 40-degree limit, catching the water with silt pits, slowing the flow with stacked fronds, and armoring the soil with cover crops, you keep your topsoil and your expensive nutrients securely on your land.
It is a total transformation. You go from a degraded, dry slope into a highly resilient, moisture-rich farming system. And, as you walk your fields this week, managing your frond stacks or planning out your silt pits, I want to leave you with something to ponder. Think about that unseen world beneath your feet. We talked about planting those leguminous cover crops to protect the surface dirt. But as those cover crops establish themselves, how might their root systems be interacting with the deep roots of your oil palms?
Oh, that's an interesting thought.
Right. Are they just blindly competing for space down there in the dark? Or, as modern botany is starting to suggest, are they secretly forming a cooperative underground network? During the peak of the dry season, could the root systems actually be sharing that trapped moisture from the silt pits, communicating through fungal networks to keep the entire ecosystem alive? It definitely makes you look at the ground you walk on entirely differently. Remember to visit our AI farming assistant at cropdrive.ai to learn more on how to increase your oil palm yields and incomes. Thanks for listening.